Okay. Welcome, everyone, to this session titled SDMX 3.0, a new chapter in the global exchange of statistical data. My name is Luca Gramaglia, and I will be the chair of this session. And I am joined by three wonderful presenters, Mr. David Baraklaw, Mr. Edgardo Greising, and Mr. Abdullah Gozalov. But before I start talking about the topics of the session and I start introducing the participants, I would just like to welcome you and set a few, let's say, ground rules for our hour together today. So first of all, we will have three presentations by our three presenters. The presentations will be will last around 15 minutes each, and we foresee to have a question and answer session in the end. If during the presentations you have any burning questions that you would like to ask the presenters, please type them in the chat of the virtual room, and we will address them when the speaker has finished speaking. I would like to ask you as much as possible to keep your mic turned off during the course of the session, and to share your questions via chat. If we do see that an oral intervention is needed in order to make it easier and clear what the question is, then obviously we will give you the floor so that you can intervene. But in general, if you can ask the questions via chat and keep the mic turned off, that should improve the audio quality for everyone involved. So those are basically the ground rules for the session, and I will therefore start introducing a bit our speakers and the topic of the session. So during the next hour, we'll talk to you about the SDMX standard for data and metadata exchange. This means that SDMX is a standard that has been around for more than a decade now. Actually, it's getting closer to 2 decades. And that has been used by national and international organizations that produce official statistics to exchange data and metadata on a worldwide scale. And there's a new version of this standard that is about to be released, which is SDMX 3.0, which will be will bring many features that hopefully will help us improve the way national and international organizations involved in the productions of official statistics exchange data amongst themselves. So in order to talk about this, we have our three presenters. First of all, we have David Baraklaw. David is a Smart Data Practices Manager at the OECD, and he leads the SDMX modeling team at the OECD. And he has a long experience in IT system development for the last 30 years. David is also the chair of the SDMX Statistical Working Group, which is one of the working groups which maintain some of the core parts of the SDMX standard, those related to statistical modeling. And he's also involved at UNEC level in the Modern Stats Standards Working Group. David will be introducing the use cases for the SDMX standard, because we realize that many of you may not be very knowledgeable or may have heard only for the first time about SDMX. So we want to give a brief introduction about what it is, what it does, and what we want it to do in the future. Then we have Mr. Edgardo Greising. Edgardo is the head of the Knowledge Management Solutions Unit at the Department of Statistics at the ILO, the International Labour Organization. And he has really wide-ranging experience in data processing, operations management, IT development. And before joining the ILO, he developed many of these, a lot of his experience working in the National Statistical Office and the Social Development Ministry of his home country of Uruguay. And he's a member of several committees and working groups that work on the modernization of official statistics. For example, the UN Geospatial Network, and he's the chair of the SDMX Technical Working Group, which maintains the technical SDMX standards. And then finally, and Edgardo in his presentation will talk to us about SDMX 3.0, the new version of the SDMX standard, and what kind of changes it will bring and what kind of new use cases it would allow us to address in the global exchange of data and metadata. And then finally, we are joined by Abdullah Gozalov, who is a statistician at the United States Statistics Division. He has a lot of experience in designing and developing statistical information systems. And for the last 10 years, he has focused on the SDMX standards and capacity development projects in national statistical offices. And Abdullah is also the coordinator of the working group on SDMX for the SDG indicators. And during his presentation, he will show us a bit how the new features that will become available with SDMX 3.0 will be used in practice in an actual implementation project for the global exchange of SDG indicators, of Sustainable Development Goals indicators. So before I leave the floor to our speakers, I will just say a few words about myself, your chair for this hour. My name is Luca Gramaglia. I work in Eurostat, and I am responsible for the team. I'm responsible for the team in charge of our data and metadata exchange standards. And I'm also involved in the SDMX Secretariat, which is the main body governing the SDMX standard. But I think I already talked too much, and I don't want to steal time away from our the presentations that await us. So without further ado, I would like to once again remind you all, if you have any questions, please type them in the chat during the course of the presentation, and we will address them either at the end of the presentation, of each presentation, or during the Q&A session at the end. And with this, I gladly give the floor to David Barraclough, who will talk to us a bit about the use cases for SDMX, and both the current ones and the futures ones that we want to start addressing with SDMX 3.0. David, the floor is fully yours.
Okay, thank you, Luca, and hello to everyone. So I'll just share my screen. Luca, if you could just tell me when I do that you can see it correctly. So I go to presentation view, slideshow. It's just starting. Oh, I think I have to do.
Perfect.
Okay.
We see the first slide. Everything looks good.
Everything looks good. Okay. Okay. So
yeah.
Okay.
In case anything goes wrong, I'll let you know quite quickly, David. Don't worry.
Okay. Thanks a lot, Luca. So yeah, thank you very much for the introduction. So yeah, my name's David Barraclough, and I'll introduce SDMX basically. You know, give an overview of you know, how the initiative started and what it's used for. And this will serve as a kind of, you know, run up to my fellow presenters who will follow, you know, such as Edgardo, who will talk about the new version, SDMX 3, and Abdullah, who will talk about, you know, a very important implementation of SDMX. So, you know, my fellow presenters will very much hang details on the things that I will introduce and give a lot more meat to those things. So, so let's start by what is SDMX? I mean, okay, there's some repetition to what Luca said here, but it stands for Statistical Data and Metadata Exchange. It started in 2002 as an initiative to really improve the exchange and efficiency of statistical information, you know, and exchanging this information between agencies. This was its kind of core use case at the start. There are 7 sponsor organizations. I'm not going to read them out, but you know, these are international organizations around official statistics. And in 2013, SDMX became an ISO recognized standard. So SDMX, what does it consist of? So it's actually a set of standards. It's not just one standard. And also with the standards, there are guidelines, okay? So, and the guidelines are very important to, so accompanying, you know, the actual kind of technical rules on what you must implement to use SDMX, the guidelines actually tells you how to get the most from them, okay? So how
David, sorry to interrupt you, but you have been muted. I don't know if you did that yourself or if something happened. But yes, you were starting to talk about the guidelines, so you were just muted for 20 seconds. Sorry.
Okay, thank you, Luca. Okay, I'll just start on this slide again briefly. So SDMX is a set of like the technical standards, but also accompanying guidelines, which help you get the most out of the standards, such as you know, best practices. So you don't go down a kind of wrong path and do something which means that your metadata isn't harmonized and the exchange of that metadata and data you know, isn't done in the best way. But of course, there are technical implementation notes because we need this to work in our IT systems, etc. So in these technical standards, everything is built around the SDMX information model. So whether, you know, we're talking about the guidelines or the technical rules and the notes or the things like XML schemas, these are all done in reference to the SDMX information model, and the information model is designed very much for statistical exchange. You know, this is its power. There are also like data web services which standardize querying data, so it makes it much easier for data collectors to get SDMX data from different sources, okay, because they can use the same systems to query these different sources and different statistical domains. And there's also a metadata registry standard. So when we're storing all this the structural metadata in SDMX, you know, how a data set should be structured, like how many dimensions go into it, what are the codes. There's this kind of system called a registry, and the kind of how to say, the interfaces of that, they're standardized as well. And something in SDMX, all this kind of standardization and the information model, it leads to a raft of reusable tools, which are mostly free and open source. You can see what they are on sdmx.org, which is the official website for SDMX. And there's a tools section there, and you can see that there's a long list of tools. There are more that are being developed, and you can take and freely use the most of them. And these range from, you know, connectors that simply get data, SDMX data into an R data frame or Stata or SAS or several other things, to full data warehousing platforms, which you can implement, which will give you, storage of data, like data explorers, APIs, mapping functionality, etc. I'm clicking and I'm not moving. So next, okay. So just some things which STMX is not, or it's so much more than this. It's not just a technical format. Sometimes people think, oh, STMX is just like a file type, an alternative to Excel or a CSV. It's not just that. It's so much more than that. It's things I talked about on the previous slide. It's certainly not tied to a single tool. So, if you're going to implement STMX, you don't say, okay, now I've got to buy this tool in order to use STMX. What you should do is to look at the tools that are available and decide, how to build out your IT infrastructure with reference to the strategic decision that you've made, to implement STMX and which use cases you want to cover. It's not for profit. The governance of STMX is the official statistics community. The private sector can freely adopt it, and we're seeing more and more of that. And it's not a closed standard as well. It's an ISO standard anyone may implement. We do public reviews on when we're changing the standard, such as STMX3. So some of the main benefits of STMX, well, as I said, the main use case is to boost the exchange and dissemination of official statistics. It also saves money and resources through the use of reuse of systems for several statistical domains and across agencies as well. So, traditionally we've seen like silo systems that are built by one agency or for a particular statistical domain. And then when you want to do more or less the same thing in another statistical domain, then a new tool is built. Well, we want to kind of stop that and through the standardization using STMX to be able to use the same tools across domains and agencies. And this is what we've achieved in many parts. So it also helps avoid the costly kind of validation of data and fixing round trips. So when we receive an STMX data message, there's validation built into it, and we can see that everything is coded correctly, or at least it's part of the specific code lists, which helps reduce some validation round trips. And as I said, most tools are free and open source. The quality is improved because when we create these like standard code lists or standard metadata in STMX, they're usually built on standard classifications. And of course, the standard classifications have already been kind of tested and proven, and the mappings are reduced because they're usually implemented already in different agencies. Automated processing through the implementation of these STMX tools helps reduce manual intervention errors by the construction of processing pipelines. And timeliness is improved because when you put these automated workflows in place, then there's not these delays waiting for a manual intervention like a button click to move to the next stage. And of course, the time to market to actually set up a statistical domain exchange, it's reduced because we're reusing these shared systems and tools rather than having to develop them ourselves. So just some common STMX tools here, but the list is a lot longer than this. There's something called the STMX registry. So this is used to store STMX information, such as data structure definitions, how a data set is actually kind of structured, like the dimensions and code lists and things like that. The main one here is the global STMX registry. So, I mean, this link, if you look in the slides afterwards, or if you just Google it, then you'll come to the global STMX registry. And here is stored the reporting templates for things like national accounts, balance of payments. And these have already been agreed between the international institutions. So it's like the way to codify those domains. Okay. And there's also the Sustainable Development Goals, which Abdullah will talk about later on. There's something to convert and transcode data called the SDMX converter, which is used all over the place to kind of get started with SDMX. Another tool which has been implemented in many, many countries called the reference infrastructure. And this kind of goes one step further than the converter, or several steps further, because it allows you to use your existing non-SDMX data warehouse or database and keep the data there. And then with this tool, you can, why would you use this tool? Well, if you want to expose your data using an SDMX web service, you can use this by keeping your existing data where it is. And this tool allows you to connect to your existing database and expose it through an SDMX web service, basically. This is what it does simply. And this is a free tool. You can see it on the SDMX.org site. And then there are also full data warehouse platforms like the Statistical Information System Collaboration Communities.stat suite. Okay, so this is an open source toolkit which gives you a data warehouse, data explorer, a lifecycle manager in order to actually edit the data. And there's also the eStat SDMX toolkit, which is a similar kind of platform, giving you many aspects of the storage and tools that you need to work with SDMX. So now we'll just go into some common SDMX use cases, just at a high level, where I describe what you need in general and how to do it, how to put these use cases in place. So say if you need to report national accounts, okay, in SDMX. So what you will need is the national accounts global data structure definition, or the reporting template. You will need a mapping from your current database to the global DSD, okay, to the global reporting template. And you'll also need a tool such as the SDMX converter or the reference infrastructure or a full platform. Okay, you should choose which one of those you want to go with. So how do you put this in place? So you can do one of three things depending on how you want to approach it. So at the simplest level, you can fill in the Excel questionnaire for national accounts and then convert it to SDMX using the SDMX converter tool. Okay, so this is the fastest thing to actually do. Okay. The next kind of complexity, but I guess the more payoff, is that you can use the SDMX reference infrastructure. You implement this, then you create a connection between your current data and the global DSD. You create this mapping, and then you can expose your data. And then one step further again is to implement a platform, a full platform such as the SysCC.stat suite or the iStat toolkit, where everything is already set up in the national accounts data, okay, because you have it kind of natively in your agency. So what are the difference between these apart from the time to set up? So if you use the SDMX converter, it's easy to set up, but then you have to send the converted file to the collectors, to the international organizations. But if you use the reference infrastructure or the platform, then you can simply say, okay, I've made this data available, so come and get it. Okay, you've already set it up, so you don't have to keep on sending this data off. So then, in the long term, you probably have more payoff doing that. So second use case is, okay, so if you want to collect SDMX statistics, what you will need is an agreement, an arrangement between the exchange partners on the data that you want to collect. So this could be that you want to use a standard reporting form like a global DSD for national accounts, and a means of reporting that you want to actually get this data. So either you agree that you will receive a file that is kind of sent to you, or that you will go and get the data by pulling it from an SDMX web service. So you agree on how you're going to get the data, and then you will need to map the reporting form data, the data that you're collecting basically, to your database. And you also need a tool to actually do the importation of this data. And then the steps to do it. So yeah, so you agree, you put this agreement in place. You create the mapping between the SDMX data and the database, and then you use the tools that you've decided on to import and remap the data, and then you have the data that you wish to collect. This final use case. So say if you want to, have all this data and you want to disseminate it using SDMX. Okay. So you will need the data in the database, obviously. You will need a tool that can actually disseminate this data as SDMX. And you will need an endpoint for which where people can come and get this data. Okay. So how you can do this? Well, you put your data into the database, and then step two. So if you don't have a database that gives native SDMX dissemination, then you implement a tool that can do that. So like the reference infrastructure can do that, and then you need to connect it to your database. And then if you want to, if the data that you're exporting should be in a different structure to your internal structures, then you have to create the mapping. Okay, you don't have to do that if you just want to export it in the same structures. And then you usually have to do some configuration of the web service endpoint. Okay. Obviously, there's quite a bit of detail there, but this is just at the high level. So those are kind of three use cases, just showing what you need and just generally how to do it. Some of the use cases, because now I'd say SDMX is kind of it started as something to improve exchange, but now it's gone beyond that to kind of really improving metadata management. So you can use it to simplify and document your data flows. Organize your in-house statistical metadata. There's been quite a bit of that. Improve the governance of the metadata. Certainly improve the design of data sets to harmonize, the metadata in-house. To exchange reference metadata. Automate validation, data provisioning. Put these APIs in place to let people come and query your data, and just there's other best practices as well which are covered in the guidelines, such as how to do embargo and confidentiality, at least how to mark up the data in a harmonized way. So I think this is my final slide. So what I've been talking about is SDMX, from version 2.1, which is like the current version, before that. But there's the new version coming this year, SDMX 3. So why do we need this? Well, the reference metadata exchange we've seen is too complicated, really, in the current version. So it's been difficult to actually, implement and voila. The next one is geospatial data. We really need a formal expression for this. can do it, but everybody will be doing it the different ways. So this is in SDMX3. We need a more natural way for modeling microdata as well, because at the start SDMX was very much for aggregated data. So now we're building into the model this better way of more natural way of doing microdata. To kind of extend code lists as well, rather than just like copying and pasting code lists when there's a new code required. Now we can say, okay, you want to add a country to a code list, well, we can do it with reference to the previous code list and just add the country, and it's all nicely integrated. Improving version dependency management, I'm not going to go into that, but definitely needed doing. Improve mapping, multiple hierarchies, improve the SDMX APIs. There's been quite a few things there that allow, such as this one, allowing querying data, which is not just part of the series key, but this is still an important query. And simplify and consolidate the standard. There were already several different formats in SDMX. And what we've done is we've kind of retired some of the older ones, so it's much simpler to decide what to use, especially for newcomers to the standard. So yeah, thank you very much. Yeah, I realise that there's a lot of information packed into those slides, but yeah, hopefully some questions, and now I'll hand back to Luca. Thank you very much.
Thank you very much, David, for the introduction. Yes, I'm sure there was, for those who are new to SDMX, there was quite a bit of information about the standard and the use cases, but I think it was needed as a basis for the next presentations. During your talk, there was one question that came to the chat about the relation between SDMX, GCM, and GSBPM, but I would suggest that we don't lose the momentum. That we keep that question in our back pocket for the Q&A at the end. It will be for you, David, you know that. And that we go straight to Edgardo for the second presentation on SDMX 3.0 and what it will bring. Edgardo, please.
Thank you, Luca. I would need David to stop sharing his screen so that I can share mine. This, okay. Okay, thank you very much. It's better now. As I was saying, the new version, SDMX 3.0, is the response to 10 years of experience using SDMX 2.1, basically, and a number of improvements has already been done, but it's true that there are many requirements not fulfilled by the version, and most of them were part of the roadmap, the vision of SDMX established in 2016. And by trying to accomplish this roadmap is that we realized that a new version was necessary, because there were many requirements that were impossible to fulfill without having a disruption. So that's the reason why we have this new version now. So I will start from David's slide that listed reasons for SDMX 3.0, and we'll try to go as fast as I can, otherwise it will take too long. But to give you an overview of how the new version implements this requirement. So first of all, reference metadata. As David said, managing reference metadata in SDMX 2.1 is very complicated, because the reference metadata had to be reported against structures. It was not possible to have reusable metadata reports. That is a request, has been requested for many users and implementers. So in SDMX 3.0, we have changed the way that the reference metadata artifacts, the metadata structure definition and metadata flows are connected to data. so that now it's much more flexible for different levels of linkage with the data. And also the API has been improved in a way of being able to do a better query of the reference metadata. So this is the very first improvement that really will help both users and implementers to have a easier way of dealing with that, and much more effective and efficient, I would say, because it will keep all the good things of the reference metadata management that has to do with the presentation capabilities, but will be much more flexible in the way of this metadata being attached and reused. Second point in the list is geospatial data. We all of us working in statistics know how popular and useful has the geospatial information been becoming in the last years, and there were no way of storing and dealing with geospatial information in SDMX until now. Of course, that you could be able to transport geospatial information in SDMX, but not in a standardized way. So if you wanted to put some geospatial information in a SDMX 2.1 data message or data, you should create your own structures and share it as part of the metadata to explain your counterparts how the spatial information was stored in your DSD. So now in SDMX 3.0, we have created 3 ways of implementing geospatial information in a standard way so that it will be known as part of the standard specification. The first format is a simple one that is just an indirect reference to geospatial information, but the standardization here comes with the name of the attributes where these references are stored. The second format, that is the more elaborated, and I think that is the real new geospatial information capabilities, is a possibility of storing geospatial coordinates based on a new data type that we call geospatial information, so that you will be able to store natively any type of geo features, that means areas, lines, points, wherever, so that all this type of geospatial information will be possible to be modeled in a DSD and transmit in any data flow. The third format is by means of using geospatial enabled code lists in 2 flavors. The geo code list, that means that you will be able to add geospatial information associated to any item that has, let's say, geographic characteristics. Let's say the typical example, we want to add the map of your reference area code list, or the map of any type of geographic area. You will be able to do it in a native element that we call GeoFeature set. Or if you define a grid, that is something that is becoming quite popular. You know, in Europe, there is a geographic grid defined for minor areas, and also Google is using this approach for their own services. So there will be a way of defining a grid code list to implement grids in SDMX. Third point, better way or natural way for modeling microdata. David says SDMX was meant to basically exchange aggregate data, and there are many characteristics of SDMX that are not compatible with transmitting or exchanging microdata. For example, and very importantly, that you had only one measure. And in microdata, you don't know how many measures you may have. But it's not only that, there are many other characteristics that now in SDMX 3.0 are so that you can store microdata natively and efficiently in SDMX. So this is a myth that we are now overcoming, that SDMX is not valid or not useful for storing and transmitting microdata. No longer valid sentence. Code list extension. The typical use case for code list extension is to make use of a standardized or a global code list in a, let's say, local context. In the past, if you wanted just to add one code or a small set of codes that you needed for your particular purposes to a standard code list, you were not able to do that unless you appropriate the standard code list and then create your own version of the code list. Now in SDMX 3.0 with the code list extension feature, you will be able to dynamically add your codes, the codes that you need locally, to the standard code list, so that you will be able to make the maintenance of only your portion of codes and let the international agency in charge of maintaining the standard code list continue to do that. This feature in particular is very useful also to resolve a very old use case, that is the discriminated union, that is the possibility of choosing one up to several variants of classification. For example, if you have a code list for classification of industries, a classification of economic activities, you know that there are countries that use NACE in Europe, and countries that use ISIC release 4, others use ISIC release 3.1 still, or others use their own national classifications like New Zealand, Australia, or United States. So today, if you want to fulfill all these cases, you have to have a huge code list that includes all these variants, and then you will be transmitting thousands of code that are useless because you normally deal with only one of these classifications. With the code list extension and discriminating union use case, you mean that you will be able to select only the subset of code that you need at the moment that you are going to use this code list. Version dependencies. Well, everybody that has dealt with SDMX 2.1 or prior version knows how complicated it is just to add a code or delete a code in a code list, and all the dependencies that has to be also changed, that almost the whole system will suffer from this small change. Now with semantic versioning, because the changes are qualified as major, minor, or patch, you will be able to deal with that in a much more flexible way, also because there will be wildcarded versions possible to be used, so that in your artifact, you will be able to say, give me the latest version, doesn't matter if it has changed or not, I will be able to deal with it. But this is also a huge improvement in terms of flexibility and simplicity, the two main drivers for this SDMX 3.0 version. A number of new features has been also defined and implemented to facilitate the mapping of structures and deal with structure sets and mapping sets. Multiple hierarchies, the hierarchies management, the HCL in SDMX 2.0 was not very simple to use, was not intuitive. So the new version has to get rid of this complicated structure, just has simplified the version, the definition of hierarchies, and now it's much more simple to use and to implement hierarchies. Last but not least, the SDMX API has been simplified, made more coherent, and has been is now allowing to do much more complex queries than it was before. And actually, it is now in ways that are not possible to be done due to the combination of keys. This is in a very quick view, all the features. And now I want to take also some of the examples that David mentioned, quickly see some use cases that how this would be benefit by the use of SDMX 3.0. So, for example, the organization of statistical metadata. Yes, SDMX always was a good standard to organize your statistical metadata, but it was complicated because, as I mentioned, the use of reference metadata structures was very complicated, and even it was complicated because it was so difficult to implement that there were very few tools could be used for dealing with reference metadata. Now, with the simplification made in SDMX 3.0, you will be able to reuse structures, and we are sure that the number of tools dealing with reference metadata in SDMX will increase to the level that of the tools that we have today to deal with structural metadata and data. The structural metadata governance will be much more easier because there will be simpler to use structures. As I already mentioned, the extension of CodeList will help in dealing with your local variants that is a nightmare because you have to maintain external CodeList as if they were yours. Also, the dealing with hierarchies will be much more simple in the future. The new API also will have limitations querying data that today you cannot do. For example, this query that is there that get unemployment for women and need for all individuals. This is a query you cannot do in operation 2.1. Here there are some quick examples of how the new component operator will allow to combine different queries, different key-related queries, or even attribute-related queries, something that also is not possible today. You cannot query for data based on the value of confidential status attribute, for example. Today, the only logical operator is OR. Now, with the new approach of the API, the new implementation, you will be able to use other logical operators, including and in the keys. One very important thing is that to query for data today, you only can refer to the data flow. So the context of the query was only given by the data flow. Today, now in SDMX 3.0, it will be possible to retrieve data from, for example, many data flows that share a single DSD just by specifying the DSD in the data query. That's all for now. I hope I am on time and happy to answer to any questions from the audience.
Thank you, Edgardo, for the presentation. I didn't see any questions from the audience pop up in the chat during your talk. And I mean, here you explained a bit all the different new features that will become available in SDMX 3.0. Those among the audience who have a good knowledge of SDMX probably understood everything. Those who don't will find the next presentation by Abdullah very helpful, because he will show in a concrete use case, in a concrete implementation projects, what the new SDMX 3.0 will bring. And I think for those of you who don't have much experience with SDMX, it will make some of the concepts that Edgardo mentioned very tangible. If you allow me just one comment, Edgardo, you mentioned, I like the choice of wording you had, that the new SDMX 3.0 will make it easier to manage local variants. And I think that's a problem that everyone now, not only SDMX experts, are struggling with. Obviously, we're talking here about local variants or code lists, and classifications, but I think it was a nice choice of wording. Abdullah, the floor is yours.
Thank you, Luca. And let me start my presentation. Okay, can you see my presentation?
Perfect.
Yeah, thanks. Okay, so thanks everyone for joining this session. My name is Abdullah Gozalov. I'm a statistician at the United Nations Statistics Division. I coordinate the SDMX SDG working group. And in this presentation, we'll talk about the data and metadata exchange for sustainable development goals indicators and how SDMX 3.0 will impact it. So first, a little bit of history. I think that the sustainable development goals are prominently featured in this event as well, but if we go back to where it started, if we look at the General Assembly resolution transforming our world, the 2030 Agenda for Sustainable Development, the resolution passed in 2015, this is what it says about the data to monitor sustainable development goals. They will be rigorous and based on evidence informed by country-led evaluations and data which is high quality, accessible, timely, reliable, and disaggregated by income, sex, age, race, ethnicity, migration status, disability, and geographic location, and other characteristics relevant in national contexts. So the Sustainable Development Goals, the largest development program in history, it's needs to be underlined by a robust data and indicator framework. And so the interagency and expert group, which developed the SDG indicator framework, established the working group on SDMX for SDG indicators. The working group is composed of 12 countries and 10 international agencies, currently chaired by Mexico. The objectives of the working group have been to develop global data structure definitions and metadata structure definitions in support of SDG indicators, as well as to develop pilot and establish data and metadata exchange mechanisms for SDG indicators. So if we go back to the General Assembly resolution, we will see that the requirements for the data set are quite challenging. The data set needs to be very highly disaggregated on the one hand, and on top of that, it clearly says that the data exchange solution must be customizable for the national context. That is, you can't create a one structure to rule them all. The structure needs to be customizable, needs to be adaptable for each country's national purposes. So these are the challenges, but the opportunities that SDMX brings are really significant. The uniform data model, you can with SDMX you can read and correctly interpret data from any source, uniform access and dissemination, SDMX application programming interface, and all the other benefits that David and Edgardo talked about in their own presentations. So the SDMX SDG working group released the first official global data structure definition for SDG indicators, basically the structure that allows us standardized packaging of SDG indicator data in 2019. The data structure definition is updated up to 4 times a year to keep up with the developments of the global data exchange. Data exchange has been established with both countries and international agencies. The data structure definition is used very widely in the dissemination of national SDG indicators. And we also successfully piloted reference metadata exchange in 2020. So all this background is important when we talk about the challenges that have been encountered in the data and metadata exchange for SDG indicators. And the first challenge is customization of the global structure, of the global data structure. Luca has just mentioned that creating local variants is a perennial problem in statistics. This is especially pronounced in the case of the SDGs, which, as mandated by the United Nations General Assembly, needs to be customizable for the national context. In SDMX 2.1, in the current version of the standard, inheritance or customization are not explicitly supported. So that means if you want to, what do you have to do if you want to customize the global structure for your national purposes? You have to download the global data structure. You have to take ownership of it. You have to make it yours, a local variant. You have to take ownership of all the affected code lists. Then you go through each and every code list and you add your national extensions to it. You take the reference area code list and you add your subnational reference area codes. You take the indicator code list and you add your national indicators, and so on and so forth. basically, this involves a lot of copying and pasting. And then you must remember to update the versions of those code lists correctly, both in their own code list, both of the code list itself and the data structure which references those code lists. Okay, and then finally, you have created your local data structure, but it doesn't stop there, because the global data structure is updated up to 4 times a year. And if you want to stay in sync with the global structure, then you have to repeat this process, or a large part of this process, every time the global structure is updated. So this process is very largely manual. It involves a lot of copying and pasting, very labor intensive, and quite prone to error, which we see all the time. So how is this going to change in SDMX 3.0? Well, one of the key improvements in SDMX 3.0 is the inheritance of code lists. What it means is that you no longer have to create your own code list that will encompass both the global and the entries and your national extensions. What you can do instead is simply create your own local code list with only those entries that are relevant to your use case. For example, a code list with national indicators, your own indicators that are not part of the global framework, or a code list for subnational reference areas, which are also not part of the global code list. And then what you do is you simply add a reference to the global code list. You don't have to copy and paste the values into your own code list. You just provide a reference. And so the process is not only simplified, not only is the initial process simplified, the maintenance is greatly simplified. And with semantic versioning, it's simplified even further. You don't have to do all that copying and pasting. You just provide a reference. And again, semantic versioning further helps here. So this is going to make a lot of difference to those, especially countries who use the data structure, the global SDG data structure definition, and customize it and use it for dissemination. The maintenance of this DSD is going to be greatly simplified, and it's going to be much less prone to error. So secondly, reference metadata. Again, Edgardo has spoken about that quite a bit, and David as well. But in SDMX 2.1, the structural maintenance and reporting of metadata is completely separate from data reporting. It's done in parallel. Metadata depends, reporting depends on data structure. Metadata structures depend on data structures, but they are, but the data structure sort of have no knowledge of the metadata structures. The reference goes one way from metadata to data. To specify target of reference metadata is actually quite complex, and validating it is even more complex. Linking data to reference metadata is also quite complex. And in the case of the SDGs, it requires querying 2 separate APIs. You have 2 completely separate APIs, one for data, one for metadata. And linking data and metadata is actually fairly challenging. And again, the crucial, I think that in the case of SDMX 2.1, it was sort of a vicious circle in the case of reference metadata. Because reference metadata exchange was so complex, very few tools were developed in support of it. And because there were very few tools in support of reference metadata exchange, it never really took off in the way that data exchange has. So, in that light, actually, the pilot SDG reference metadata exchange is quite an impressive achievement, because we managed to overcome all these difficulties. And this experience, I think, in large measure informed, it provided a lot of input to the development of reference metadata support in SDMX 3.0. But because of the lack of tools in support of reference metadata exchange, in the case of the SDGs, everything had to be developed basically manually. All the tools had to be developed to author metadata, to retrieve metadata from reports, to transmit it, and so on. So how is this going to change in 3.0? In 3.0, there are a better distinction of several types of metadata, and those metadata which are close to the data, for example, which describe methodology and quality characteristics of your data collection, or methodology characteristics of your particular indicators. These metadata can be declared as part of a data structure, not separately as part of a metadata structure. So the reference metadata can now be reported, all these methodological and quality aspects can now be reported as part of the same data set. That is, you can send reference metadata and data to which it refers in a single message, or you can choose them, so you can choose to report them separately as well. You have this choice. You can use the same API for reference metadata and for data. You can greatly simplify the linking of data and reference metadata. And again, most importantly, we expect that commonly used tools which already support data exchange will also support metadata exchange, and this will further simplify reference metadata exchange for reporters. And the third aspect I'd like to draw your attention to is the geospatial information. In SDMX 2.1, as Edgardo mentioned, there was no explicit support for geospatial information. We still implemented support for geospatial in the case of the SDGs through the use of two geospatial attributes that can provide links to external resources, to external geospatial files. But what are the implications? The implications is that these links, the links to geospatial files, they are part of the data set. They're part of your data, not part of the structural metadata where it normally belongs. That means that you have to repeat a link to a particular, let's say, a map of your province or a state. You have to repeat that link for every series in your data set. This is redundant. This blows up the size of your message. And this basically creates potential for all sorts of inconsistencies in there and makes the maintenance of it quite difficult. In 3.0, the integration of geospatial and statistical information is going to be really greatly simplified. You can embed geospatial information in your structural metadata where it very often belongs instead of the data. That means that you declare, first of all, you can remove the dependency on external resources. You don't have to reference external files anymore. You can embed geospatial information in your structural metadata. That's one. Second, because it's part of the data structure, because it's part of structural metadata, you don't have to put it into your data set. You only declare it once, and then it's reused every time by the user without needing to transmit that information in the data. So you have reduced potential and reduced cost of errors. Your redundancy is eliminated, and dependency on external resources is going to be also eliminated. If necessary, you can still embed, just in the future, it might be possible to embed geospatial information in a data set in a different use case. And this brings me to the end of my presentation. SDMX 3.0, just the last word, SDMX 3.0 is going to bring many benefits. It basically reflects, I think, about 10 years of experience of wide-scale data and metadata exchange. But these three aspects, codeless inheritance, reference metadata, and geospatial, are probably the ones that stand out in the case of the SDGs. And this is what we covered in this presentation. Thank you for your attention. Back to you, Luca.
Thank you very much, Abdullah. I think this was a very good presentation to really see the practical implications of the features, of the new features in SDMX 3.0 in to help us with the challenges of exchanging statistical data, metadata at international level. We do have a couple of questions that have accumulated over the course of the session, and on which I would like the different speakers to provide some comments. One is for David, but David has seen it already. It's been the question was about the relationship between SDMX, GSIM, and GSBPM. So since this question was made a few minutes ago, I think David, you have an excellent answer prepared for this.
Thanks, Luca, and thank you for the question. But I just wondered, I'll respond, but I just wonder if Edgardo wants to add something actually, because he's in the same standards group as me working on these models. So what I'll say is, I think GSIM and GSBPM, they are kind of models more for kind of architectural analysis and kind of business architecture analysis. So GSBPM, this is on the kind of process or activity model of an organization, and GSIM is more like how the information flows between these activities, but at quite an abstract level. Okay, so they're very good for analysis. But there aren't many tools actually based around these standards, okay? But something like SDMX, this is much closer to like an implementation of certain use cases. If you actually want to do something like exchanging data, like modeling your data or transforming your data, this is where SDMX comes in, and there's lots of tools to actually, put that in place to make it happen. And the same goes for DDI. If you know the DDI standard, I think it's on that level, it's like the same as SDMX, but of course SDMX and DDI, they have, quite different use cases. So SDMX is more around, exchanging of this data and structuring the data, whereas DDI is much more about, describing surveys and reusing this kind of survey level metadata and around describing the lifetime of variables, to trace it over time, and modeling of paradata, things like that. So, and yeah, well, I think I'll stop there. I could talk a lot more about that, but I just wanted to gather you want to add briefly.
Thank you. Oh, go ahead, Luca, you are the chair, sorry.
No, go ahead, Edgardo. I just wanted to give you the floor. Go ahead.
Thank you. No, basically, I think that David explained very well. I mean, the only thing that I can say, just in different words, is that while GSIM and GSBPM are reference models, SDMX is an implementation standard. So there is a relationship between them because SDMX follows the recommendations of GSIM and GSBPM. So you can map SDMX artifacts to GSIM objects. You can map SDMX processes or processes in which you can use SDMX into GSBPM processes and sub-processes, phases and sub-processes, sorry. So the relationship exists and is observed in both directions. But they are different in scope, they are different in objectives. GSIM and GSBPM are reference models, are recommendations. SDMX is a technical standard, among other things, as was already explained by David in his first presentation. But in terms of standardization, is a technical standard for implementation that is different from a reference model.
Thank you very much, Edgardo, for complementing David's answer. I would like to, there's another question that came up that I would like to address to Abdullah maybe, but here Edgardo and David may also come in. It's about the tools available for metadata in SDMX. And you mentioned, Abdullah, that yes, the reference data model in SDMX 2.1 was quite complex, meaning that there weren't many tools available on the market that deal with the reference metadata in SDMX 2.1. But would you have any recommendations, anything to mention about current tools in SDMX 2.1 that deal with metadata?
Yeah, thanks, Luca. The one tool I know which does support reference metadata for SDMX 2.1 is Fusion Registry Enterprise Edition. It does have a reference metadata authoring, some kind of reference metadata authoring tool, and it also supports reference metadata set registrations and so on. This tool is basically a commercial tool. It's not free to use. Regarding free to use tools, I don't believe there's anything for 2.1. I mean, at least I'm not aware. I invite the others to contribute. There was one for 2.0, I think it's called the SAP editor. But this is, I think it was discontinued, its maintenance was discontinued a few years ago. So there is really a dearth of tools when it comes to reference metadata exchange in 2.1. And we had to develop, for the SDGs, we had to develop practically everything by ourselves. But again, thanks to the simplification, streamlining, and improvement of reference metadata exchange in 3.0, we do expect that run-of-the-mill tools such as reference infrastructure or converter, I hope that they will support reference metadata as well.
Okay, thank you, Abdullah. Just for those that maybe didn't catch the names that Abdullah mentioned, I put them in the chat, so you can look into those tools. But as Abdullah mentioned, there aren't that many, unfortunately, right now for reference metadata, but that problem hopefully will be fixed with SDMX 3.0. So I do not see other questions in the chat. I do see, however, that a certain exodus from this session has started to go to other sessions in the ISI conference. So I would like to thank all of the participants for their participation. Before you leave, I just wanted to point you to some links where you can learn more about SDMX or about SDMX 3.0. The SDMX.org website is the first place to start if you need information about SDMX. We talked about SDMX 3.0, and Edgardo mentioned that the SDMX 3.0 standard is currently under public review. If you're interested in the standard, to know more about the details, or even to give comments, you have the link here to the to where you can do that. And then finally, the full package will be presented at the 2021 SDMX Global Conference, which will take place at the end of September of 2021. If you're interested in SDMX, if you want to register for that conference, which will talk about SDMX 2.0, but also in general about how SDMX can help streamline the exchange of data and metadata, you have the link as well available on this slide. As usual, let's say if you want to contact some of the presenters, I think the contacts will be available, or myself, the contacts will be available on the ISI website where they have been shared. So with that, I would like to thank again all of our wonderful presenters for their presentations. I would like to thank again all of the people who participated in this event and followed it. We hope to see some of you, at least maybe, at the 2021 SDMX Global Conference. So thank you, everyone, and we will hopefully keep in touch. And I see that David also shared the link to the SDMX Think Tank group, which can also be found in his presentation. Okay. Thank you, everyone. Once again, thank you to the presenter. Thank you for the to all the participants, and we hopefully will see you soon on more SDMX related topics. Thank you.
Thanks so much, everyone. Thank you, Luca.
Thanks, Luca, for the moderation.
Yeah, everyone. Bye.
Bye-bye.